So let's continue the exercise. It's AES. It's a simple exercise to apply the different step. So as we said, A, show the original content of the state. So we have to display it as a matrix, 4x4 matrix. The implementation of AES is applied as 4x4 matrix. So in this case, it's typically done by column. So it will be 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 5, 0, 6, 7, 0, 8, 0, 9, 0, A, 0, B, 0, C, 0, D, 0, E, and 0, F. So this will be the original state as 4x4 matrix, and also the key in this case will be 0, 1 in all parts. Okay. So this is the key, and this is the original state of the block. Okay. So in section B, show the value of the state after the initial add round key. Remember that the add round key is a simple XOR. Okay, so is XOR between the initial state and the key. Okay, between the plain text as initial state and the key. So typically we have to do XOR between 0, 0, 0 and 0, 1 in order to have the value here. Okay, so let's see 0. Remember that we are in hexadecimal, so 0 is 0, 0, 0, 0, and the other 0 is 0, 0, 0, 0. So here 0, 0, 0, 0, and 0, 0, 0, 1. So typically, if you want to apply XOR, in this case, to apply XOR, 1 and 0 is 1, is 0, 0, 0, 0, 0, 0, 0. So the result here is 0, 1. Okay, 0, 1. If you want to apply 0, 1 and 0, 1, here we can see that all are 0 and 0, 1. This means that we have 1 here and 0, 1. 1, 1 is 0 and all are 0, so it will be 0, 0. And we can continue like this for 0, 2. For 0, 2 is 1, 0. This is 0, 2. So here 0 and 1 is 1. 1 and 0 is 1, and the other are 0. So this means that it's 0, 3. We can continue like this and we obtain the result 0, 2, 0, 5, 0, 4, 0, 7, 0, 6, and 0, 9, 0, 8, 0, B, 0, A, 0, D, 0, C, 0, F, and 0, E. Okay, this is typically the result after applying add round E. So let's continue with the part C. In the part C, we want now to apply, and the result here, we want to apply on this block the value, show the value of state after substitute byte. So we have to use SBox in order to find the result. So we have here 0, 1. 0, 1, we should use 0 and 1. Okay, 0 and 1 in hexadecimal, 0, 1. So this is the first for the row, and this is the result for the column. Let's check on SBox. This is the SBox. So we have 0 for the line and 1 for the column. So the result will be 7C. So here, the result of 0, 1 after this will be 7C. Okay. For 0, 0, for 0, 0, it will be 6, 3. And the last one for 0, 3, it will be 7B. So that's why here we say for 0, 0, it will be 6, 3. For 0, 3, it will be 7B. And we can check also for 0, 2, it will be 7, 7. For 6B, want to apply for 0, 5, it will be 6B. For 0, 4, it will be F2. For 0, 7, it will be C5. For 0, 6, it will be 6F. For 0, 9, it will be 0, 1. For 0, 8, it will be 3, 0. For 0B, it will be 2B. For 0A, it will be 6, 7. For 0D, it will be D7. For 0C, it will be FE. For 0F, it will be 7, 6. And for D, or 0E, let's see together. For 0E, this is 0, and this is E. For 0, E, it will be D7. So we have 0D, 0C, 0F, 0E. This one, 0, and so this one was the inverse, so this is the right one. It will be 0E, it will be AB. Okay. Okay, so at this level, we did the step of substitute by. So this is the answer of the part C. Let's see the answer of the part C. We should show the state after shift row. Remember that for shift row, the first column will be the same. So it will be 5C, 6B. This is the result of D. And 0, 1, and D7. For the second, we have to shift one position. This means that 63 will be here, and F2, 30, FE. For the third row, we have to shift two position. This means that will be 2B, 7, 6, 7B, and here it was C5. And the last one, it will be inverse. This means that AB will be here, and after that 7, 7, and 6F, and 6, 7. So this is the result after doing shift row. Okay, and we want to find the value of the state after mixed column. Remember that mixed column, as we said, it's a kind of operation done here. This means that we should apply here, should apply the term, okay, by those parameter. So that's why the easy way to do is like this. Let's add another slide. So it will be like this. So the table, if I can add it 0, 2, 0, 1, 0, 1, 0, 3, 0, 3, 0, 2, 0, 1, 0, 1, 0, 1, 0, 3, 0, 2, 0, 1, and 0, 1, 0, 1, 0, 3, 0, 2 will be multiplied by the different term we talk about, which are in our case 7C, F2, 2B, AB, 6B, 30, 76, 77, 01, FE, 7B, 6F, E7, 63, C5, and 67. Here we should apply the different operation. This means that the first term we should obtain here will be equal to 0.2 times 7C plus 0.3 times F2 plus 0.1 times 2B plus 0.1 times 2AB. And we should calculate this as we explained, it will be in the Galois field 2 to power 8. So we are working here in Galois field 2 to power 8. This is a specific multiplication done in binary. It's like one bit shift. And then the addition, it's a kind of bitwise XOR. So we have to convert all those on binary and to do the operation. And after doing them, we find the value is in binary, and the result will be 75. So this is the typical way. Require a lot of calculation here. If you want the result, so the result will be 75553E 1087E 62E and 150F04 B8 5, A2, 2, 8C, and 0, 8. So this is the result after doing the different operation. So as I said, as a manual operation, uh, we can do add ground, substitute byte, and shift row, but for mixed column, really it needs calculation. So typically we do it by. Okay. So I hope that it is useful for you and you was able to understand the first step of AES, Advanced Encryption Standard. So we need to move to the next chapter where we go to the asymmetric encryption.